which have a magnitude of unit value, then we call those vectors as orthogonal unit vectors. So for discussion, I explained what are orthogonal unit vectors. Suppose you take x-axis and y-axis, you take a point here, let's say 2, 3. I drop the perpendicular. I told you this distance is 2 units and this distance is going to be 3 units, right? So from here, if I'm able to write this as a vector, then I will write this a vector is equal to 2i cap plus 3j cap. So when you read this kind of a statement, what is understood by you? So when I write it as 2i cap plus 3j cap, what is the person who's writing tell?
2i cap indicates 2 units in the direction of x-axis.
Very good. 2 units along which x-axis? You need to be specific. 2 units along positive x. Be very specific, okay? Similarly, you have 3 units along positive y-axis. Okay. In a similar way, what I can do is, if I see, I'm not going to draw a diagram. If I give a vector is equal to 3i cap minus 4j cap, if suppose I'm writing it like this, what can you infer from this information? What do you understand from this?
4 units along negative y-axis.
Very good. So how we are supposed to do is, whosoever it is, can you mute yourself? I'm getting my voice. I'm getting resound of my voice. I'm just muting you all. So when you have 3i cap minus 4j cap, no, the small rearrangement that you're supposed to do in this is, you have to write it as 3i cap plus 4 into minus j cap. This is the other way of writing, because I told you any vector has a magnitude and direction. So this vector tells us that there is a magnitude of 3 units in positive x-axis or positive x direction and 4 units in negative y direction. As simple as that, right? And one more important point is, from vectors you can relate it to the concept of coordinate geometry that you have learned last year. Okay, so how to relate it, that's the question. Now if I put a question like this, can you tell me the quadrant in which this vector is there? What will you say? I will underline the part which has the hint. I'm circling it, see. This is going to be the hint. Can you use the logic and tell me this particular vector is in which quadrant?
Fourth quadrant.
Fourth quadrant. Very good. And the reason being, you're talking about positive x-axis and negative y-axis. So when you take the quadrants concept, first, second, third, and fourth, first quadrant has positive comma positive, second quadrant has negative comma positive, third quadrant has positive comma negative comma negative, right? Negative comma negative, and the fourth one has positive comma negative. Since x is positive and y is negative, we say that this particular vector is restricted to the fourth quadrant. Okay, so this is clear. Now this is with respect to two-dimensional space. Now if I extend the concept to three-dimensional space, what do you think will happen? So how should I write? If I write a vector is equal to 2i cap plus 3j cap plus 4k cap, what do you think this means? If someone writes and gives you like this, what do they mean? Anybody?
There are 3 axes.
There are 3 axes. What are the 3 axes? X-axis, y-axis, and z-axis, right?
Z-axis.
Yeah. So x-axis, y-axis, and z-axis means, how will you read this? It is 2 units along
positive x-axis.
Positive x-axis. The same story again, nothing different. So 3 units along
positive y-axis.
Positive y-axis, and 4 units along positive z-axis. Okay, this concept, what you can do is, you can relate it to three-dimensional geometry. When I say three-dimensional geometry, you can write the coordinates of this point as 2, 3, 4. Okay, anyways, about this concept you will learn later in your math. Okay, I hope it is clear till this step. If there is any doubt, please let me know. I'll just give you 1 minute time. You can get your doubts clarified if there is any doubt. So I hope there is no doubt. Okay. Then I'll proceed to the next concept. Now what I'm going to do is I'm going to introduce the concept of mathematics into this. I'm going to explain you about addition of vectors. See, when I say addition of vectors, have this point in your mind. There are two types of addition. One is going to be the basic addition that you are going to do, and the second is called as the vector addition, that is called as triangle of vectors. Okay, that is a different concept. If suppose I have a vector like this, a vector is equal to I cap plus j cap plus k cap, b vector is equal to I cap plus j cap minus k cap. If I ask you a question, what is a vector plus b vector? What will you do? So what do you think will the answer be? Anybody?
2i cap plus 2j cap.
2i cap plus 2j cap. And what will happen to k cap?
It gets cancelled.
It gets cancelled. So from this we can understand when you have a vector plus b vector, it is normally like how you do an algebraic operation. For example, if you have x plus y and x minus y in your hand, if I ask you what is the sum of both, you're going to add the x coefficients and write 2x. You're going to add the y coefficients and write it as 0y. That's it, as simple as that. Instead of x and y, you have ijk, as simple as that, nothing outside it. So this is what is called as addition of vectors. Similarly, when I introduce the concept of subtraction of vectors, what are you going to do? And so when I ask you a vector minus b vector, what is going to be the meaning?
Change the signs.
Change the signs and write it. So you're going to write it as, so the answer is going to be I and I will get cancelled, so I will write it and show. So is it like this? I cap plus j cap plus k cap minus I cap plus j cap minus k cap, right? So what all will get cancelled? I cap and I cap will get cancelled, j cap and j cap will get cancelled, k cap minus of minus k cap will be 2k cap. So this is going to be the resultant. Okay. So I'm going to explain the subtraction of vectors in a different concept. Please listen to it. So if I say two vectors are being separated, I will say a vector is getting added to the negative of the other vector. Can I write it like this? I'm repeating it again.
Yes.
A vector minus b vector is same as writing it as a plus of minus b vector. They both mean the same because plus into minus is going to be a minus. So how I will state here is a vector is added to the negative of b vector. So what is the meaning of this negative of b vector is nothing but, so what I'm trying to conclude from this is subtraction of vectors is just the reverse process of addition of vectors. Okay, subtraction and addition are not different concepts, they both are the same. Only thing is when you're subtracting something, you have to change the direction and subtract. So for you to visualize what it is, I'm just explaining. So here, what do you mean by negative of vector? Can somebody explain me what do you mean by negative of vector?
Opposite direction to the.
It's just by changing the direction. Opposite vector, that's it. If this is b vector, if I change the direction of it, it is going to be minus b vector. That is the meaning. So if you have to visualize the same thing in terms of diagrammatic representation, observe, if a vector is like this and b vector is in some random direction, when you're adding it, just add the coefficients. If suppose you want to subtract them, then what you're supposed to do is, if this is a vector, if this is b vector, then reverse its direction like this, minus b vector. So if you want to subtract, take these two terms into consideration. This is only for you to visualize, nothing so complicated. If at all the problem is given, you can just go by this method. It is only for you to understand the geometrical interpretation of it. What exactly I mean by negation of a vector, negative of a vector. That is what I wanted to explain. Okay. So I hope things are clear. Yes, right. And the next type of vector that I'm going to introduce is called as, this is also a very, very important vector. So the next type of vector is called as the position vector. So make a note of it, position vector. So write down the definition for it. Any vector whose initial point is origin. So any vector whose initial point is origin is called the position vector. Okay, and the representation of a position vector. So how do you represent it? Representation of a position vector. What is the notation used? That is what I'm going to show you. If suppose, let me go back to the same old example. Let me take this point P as 2, 3. Okay, this is in terms of coordinate geometry. This is in terms of coordinate geometry. So in terms of coordinate geometry, this point has the coordinates as 2, 3. If I take this as the initial point origin, so if I'm able to draw it as a vector from here to here, then this vector OP with a bar on top of it is called position vector of point P. Okay, OP vector is called as the position vector of point P. So OP vector, how do you write it? You still write it as 2i cap plus 3j cap, as simple as that. Okay, so this is how you write it in the form of orthogonal unit vectors. If you have to write it in the form of a statement, you call it as OP vector is a position vector of point P. Okay, so position vectors are always represented only for a point. So point with respect to origin. So what is the important term here? It is the origin, which is 0, 0. This is very important. Okay, this is a very, very important vector. Have this in your mind because there are many problems which are based on this concept. Okay, is there any doubt? Is there any doubt?
No, sir.
No? Okay. The next concept is magnitude of a given vector. Yesterday I told you, right? Magnitude means you write it as, so how do you write magnitude for a given vector? If a vector is there, for magnitude, you put a modulus around it, as simple as that. That's it, right? But I told you there is a way to calculate it. So now I'm going to give you the formula for calculating the magnitude of a vector. So let's see what is the formula. I'm going to stick to the same example, okay? I'm not going anywhere outside it. So same point 2, 3, okay? If this is O, this point is P, then what is OP vector? OP vector is equal to 2i cap plus 3j cap. Now I want to find what is the magnitude of OP vector, okay? What is it going to be? Can someone tell me what is going to be the value? When I say magnitude, it is the distance between this point and this point. Anybody? Sorry? Anybody?
Root 13.
How did you get that?
Like we have to join point P to like we have to draw a straight line of point P which intersects at x-axis. So
Okay, you're saying you'll drop a perpendicular. Is that what you're trying to say?
So let's mark that the point of intersection as A, for example.
Okay, A.
So OA is 2 and AB is 3.
AB is 3. So according to the Pythagoras theorem, this becomes root of
13.
2 square plus 3 square, which is root 13. Is there any other way you can derive this? Very good. This is good method. So you have applied the right angle. You have formed the right angle triangle and applied Pythagoras theorem. Is there any other way to derive this? Any other logic? Same concept but different approaches. I already told you. So magnitude of a vector means distance between 2 points. I'm stressing on the word distance. So do you people remember the distance formula? So if 2 points are there, x1, y1 and x2, y2, how do you find the distance between these 2 points? Root of root of
x2 minus x1 the whole square.
x2 minus x1 the whole square plus y2 minus y1 the whole square. As simple as that. So you have 2 points in your hand, 0, 0 and 2, 3, right? So what is going to be the length of OP? So OP vector will be equal to square root of 2 minus 0 the whole square, that is going to be 2 square, plus 3 minus 0 the whole square, that is going to be 3 square. So both mean the same, whether you are going to follow right angle triangle concept or whether you are going to follow the concept of distance formula, the answer is going to be the same. But I want to give a generic formula because my concern is not only about 2, 3. I want to make it a generalized formula. If suppose I have a vector, OP vector is equal to xi cap plus yj cap, that x and y can be anything. It can be in any quadrant. I'm not concerned about what quadrant it is. But I want to define only the magnitude of it. Then what is the formula that I can give it?
Modulus of xi cap plus modulus of yi cap.
Okay, modulus of xi cap plus modulus of yj cap. What do you think will be the answer? You have a ready-made example in front of you. You just need to make it as a formula. I will underline and show you. Here for OP vector, what does 2 represent? 2 represent the mathematically 2 represents the coefficient of I cap. Right. Similarly, 3 represents the coefficient of j cap. So this 2 square plus 3 square means coefficient of I cap square plus coefficient of j cap square. Can I say it like that? Can I tell it like that? Yes or no? Yes. Then that if that is the case, then how do I write OP vector as? Square root of
Square plus y square.
as simple as that. That's it. X square plus y square. If suppose I have the vector OP vector as xi cap plus yj cap plus zk cap, then how do I write the magnitude of OP vector as? Square root of, I'm just extending it. X square root of
X square plus y square plus z square.
That's it, as simple as that. This is going to be the formula for the magnitude of a vector when it is given in its standard form. Okay, so let's take an example itself. Let's say there is a vector AB vector example. I have AB vector as I cap minus j cap plus k cap. So what should I do? Magnitude of AB vector will be equal to root of, here what is the value of x?
1.
1 square plus
1 square plus 1 square.
minus 1 square plus 1 square. So this will be equal to square root of, what is it going to be? 1 square plus 1 square plus 1. So it is going to be square root of 3. Means the length of this particular vector, if you try to measure the distance between point A and B, that value is going to be root 3 units. That is the meaning of magnitude of the vector. It is going to be root 3 units. And this formula is very important, remember. Okay, this is a very, very important formula. Right? So if someone is not clear, you can please ask me or please let me know. If everything is fine, I'll proceed. So now you understood how to calculate the magnitude when the vector is given in terms of orthogonal unit vectors, right? Now let's try to calculate a unit vector. Well, again, I'm going to revisit the concept of unit vector. I'm going to approach it mathematically. In the above process, I did it theoretically. Now I'm going to do it in terms of mathematics. If suppose there is a vector like this, a vector is equal to I cap plus j cap plus k cap. And the question is like this: find the unit vector in the direction of a vector. If suppose you see a question like this, find the unit vector in the direction of a vector, then we need to have a formula for it. That is what we are going to derive. So again, I'm sticking back to the basic. So a vector is given as magnitude of A vector into A cap. Agreed? Accepted? So this is what we had been discussing from yesterday. Now if I manipulate this equation, that is if I try to write A cap, then A cap is written as A vector divided by the magnitude of A vector. Can I say this is going to be the formula for unit vector? So this is going to be the formula for unit vector. So this is also a very, very important formula. So have this in your mind. Now I'm going to approach it mathematically. So A vector is given to me. I'm going to find the unit vector in the direction of A vector. How do I apply it? Can you apply it as a formula? So A cap is equal to, what is A vector? A vector is given here, that is I cap plus J cap plus K cap divided by what is magnitude of A vector in this case? The previous formula. Root of?
Root 3.
Root of 1 square plus 1 square plus 1 square, it will be root 3. So I cap plus J cap plus K cap, the whole divided by root 3. So this is going to be the required unit vector. So A cap will be equal to I cap plus J cap plus K cap, the whole divided by root 3. So this is the required unit vector. So I'm repeating it. You will understand all these processes slowly. As of now, what you need to concentrate on how to understand the formula and how to apply it. The physical significance of it you will understand as the subsequent chapters come into picture. Okay, as you start applying this in different chapter, this is how you need to think also. That I'll slowly explain it to you once the other chapters get discussed. Okay. So as of now, concentrate on this part. If there is any doubt, let me know. So I just want to ensure that these 3 points are clear. One is orthogonal unit vectors are clear. Second is position vector is clear. And the third one is understanding how to find the magnitude. And the last one is how to find the unit vector if a vector is given. So are all these points clear? Yes or no? Others? So if you are unable to mute yourself, just let me know in the chat box at least. I'm waiting for your responses to proceed.
Yes, sir.
Clear?
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay, then we'll go to the next concept. Okay. If at all you feel anywhere you're not able to understand, please stop me. Don't hesitate. So I'll try to explain it in a different method. So this is over. The next concept that we are going to discuss is called as triangle law of addition of vectors. Triangle law of addition of vectors. So this is what we are going to see. Okay. So write down the statement for it. If two vectors, I'll show you the statement itself. Just a minute. So I'll show you the statement, make a note of it. Triangle law of vectors. Okay. So write down the statement in the bold. If two vectors are represented, write it down. If two vectors are represented in magnitude and direction. If two vectors are represented in magnitude and direction by the two adjacent sides of a triangle taken in order. I'm repeating it. If two vectors are represented in magnitude and direction, if two vectors are represented in magnitude and direction by the two adjacent sides of a triangle taken in order, this is very important, underline this word, taken in order, then their resultant, I'll explain what resultant is. I'm repeating it. If they are represented in magnitude and direction by the two adjacent sides of a triangle taken in order, then their resultant is the closing side of the triangle taken in the reverse order. I'm repeating it. Then their resultant is the closing side of the triangle taken in the reverse order. So have this in your mind. So if you're done, let me know. If you're done writing, let me know. So for the sake of understanding, I'll just repeat it one more time. Just check your notes. If two vectors are represented in magnitude and direction by the two adjacent sides of a triangle taken in order, then the resultant is the closing side of the triangle taken in the reverse order. Okay. Let me explain what it is, what it means in a diagrammatic format. Okay. So listen. So the statement says if two vectors are taken in order, that is what is important. In order, how are they supposed to be taken? They are supposed to be considered as the sides of a triangle because the name itself says triangle of vectors or triangle of addition of vectors. Right? So if two vectors are taken like this, A and B, okay, then the closing side, then the resultant is given by the closing side of the triangle taken in the reverse order. Here, I want to stress on one point. So, I told you to underline this term. I told you if two vectors are taken in magnitude and direction by two adjacent sides of a triangle taken in order. In order means, listen to it carefully. If this is the starting point of the first vector and this is the ending point of the first vector, okay. So, what is the technical name for starting of the first vector? It is called as the tail, and this is called as the head. Okay. So, if this is the starting point and if this is the ending point, similarly, if this point, the ending point of the first vector is behaving like the starting point of the second vector, then both the vectors are said to be in order. I'm repeating it again. If the ending point of the first vector is the starting point of the second vector, then A vector and B vector, that is these two vectors are said to be in order. Okay, then the arrow mark is supposed to be here. If these are the cases, if you consider A vector and B vector along two sides of a triangle, then what are they trying to say? Then how is the resultant given? Resultant means the result. Then what is going to be the final result here? Then the resultant is given by the closing side of the triangle. If I take the side triangle as A, B and C, then A and C is going to be the closing side of the triangle. But there is one more important word that needs to be stressed upon. What is it? Closing side of the triangle taken in which order? In the reverse order. What do you mean by this? Okay. So how do you try to understand this concept? So I will give you two diagrams. Tell me which one is right. This is AB vector, this is BC vector, and this is AC. So AB and BC, we have taken it like this. Now, should I put the arrow mark like this or should I put the arrow mark like this? So if this is A vector, this is B vector, then I will call the resultant as R. For resultant in this chapter, we'll be using the symbol capital R. Okay, have this in your mind. Okay. Then, which diagram is right? Is the first diagram right or the second diagram right? According to the statement that is given here.
The first diagram, sir.
First diagram.
Reason?
It is the reverse order.
It is the reverse order. So, what do you understand from reverse order? If they are in order, what is happening? If they are in order, the tail of the first vector, the head of the first vector is coinciding with the tail of the second vector. Whereas in this case, what is happening? In the case of first vector, both the heads are coinciding. Very good. That is the reason. Both the heads are coinciding. Whereas if you take this one, no, this is a wrong diagram with respect to triangle of vectors. Because A vector and B vector are in order, B vector and R vector are also in order, R and A are also in order. They are subsequently in order. So this is not the statement that the triangle of vectors is trying to say. Okay. Then how do I write it mathematically? I am going to write it as A plus B is equal to R. Okay. So one point I want to explain it here is, I told you, see, these are just the notations, concentrate here. This is A vector. This is magnitude of A vector. See, magnitude of A vector can either be written as A with a bar on the top, with a vector symbol on the top, with a modulus, or just a symbol. If you just write the symbol means magnitude. Magnitude means length. Okay. Similarly, A with a cap on the top is a unit vector. A with a cap on the top with a modulus. This is going to be 1. So these are all the notations. So this is the point I'm going to stress upon. So magnitude of a vector has two notations. That is the vector with the modulus around it or just the symbol. If that is the case, I'm writing it as A plus B is equal to R. Okay. Now what have I written? Have I written the magnitude or have I written the vector?
Magnitude.
I've written the magnitude. Is my statement right? Is my mathematical expression right? You can just read the statement again. You read it multiple times, you will get different perspectives from it. So what is the statement of triangle of vectors telling you? Is it triangle of vectors speaking about the vectors or magnitude of the vectors? Read the statement.
About vectors.
About vectors. No. So what change should I do in this?
A vector plus B vector equal to R vector.
Very good. So I should put a vector symbol on top of it. If I don't put that, then my statement is wrong. So A vector plus B vector is equal to R vector. This is what is very important. And this is the mathematical expression for triangle of vectors. Are you people clear with this? And repeat. Clear, right?
Diagram.
Yeah. Which diagram you are not able to see?
The
This
first,
one? Is it fine now? You are able to see now?
yes.
You're not able to see, or you want me to explain? I didn't get you.
Can you explain it again?
Sure, I will do it. So which point do you want me to explain? Is there any specific point or you want me to explain completely?
No, the triangle diagram you read.
Okay, triangle diagram, right? You have the statement in front of you?
Yes.
Yeah. Those who are not clear, observe it again. I told you, see, those who spoke now, actually, who's the one who asked out? May I know the name?
Mithun.
Mithun, do one thing. No? Why don't you read out the statement so that others also understand? I'll go step by step. Read out the statement.
If two vectors are represented in magnitude and direction,
By
direction, adjacent sides of a triangle.
Adjacent sides of a triangle. Okay. Okay. See, whenever you're reading any statement, whether it is physics, maths, or chemistry, no, you should always dissect it. Don't read the statement at a stretch. Try to break it into points and convert it to a diagrammatic format. So, if two vectors are taken in order, I'm using another color, observe. Or else I'll do a separate diagram itself for you to understand better. So, I'm erasing this part. If two vectors are taken in order means one should get, so two adjacent sides. So these two are the adjacent sides. If they are taken along the sides of a triangle in order. When I say in order means the ending point of the first vector should be the starting point of the second vector. That is the meaning of in order. If you're not clear, please make a note there. Then the resultant of this triangle is given by the closing side of the triangle. So closing side of the triangle, if I take this point as A, B and C, so this AC is going to be the closing side of the triangle, but it should be taken in the reverse order. Okay, so it should be taken in the reverse order in the sense the tail of the resultant vector and the tail of the second vector should coincide. That is the meaning. So if I name this vector as R vector, then I am trying to say R vector is equal to A vector plus B vector. This is the mathematical expression for triangle of vectors. But R is equal to A plus B. This is wrong. And the reason for it is you're trying to say that the sum of two sides of a triangle is exactly equal to the third side. Not possible. It should be greater than or equal to third side if you study the properties of a triangle. Okay, but if you write the same thing in terms of vectors, yes, it is right because according to the laws of vector. You will understand this. Why it is so, you will understand it slowly. So as of now, what you can do is, as of now, see, this concept is troubling you. Understand that this is the way you write the mathematical expression. Where to apply it, once we start solving the problems, you will definitely get a clarity of it, trust me. Okay, Mithun, are you clear with this?
Yes, sir.
Okay, good. Okay, if everyone is clear, if no one is having a doubt, I'll proceed to the next law. Okay, I'll proceed to the next law then. This is triangle of vectors. The next law is called as the parallelogram law of vectors. So parallelogram law of vectors. Okay, since we are saying triangle of vectors, those vectors are represented along the sides of a triangle. Okay, parallelogram is obviously the vectors should be represented along the sides of a parallelogram, as simple as that. Okay, but there is a small difference. I'll explain you when to apply triangle law and when to apply parallelogram law. First, let's complete parallelogram law of vectors. So look at the statement here. So the statement goes like this. Make a note of it. If two vectors acting at a point are represented in magnitude and direction, if two vectors acting at a point are represented in magnitude and direction by the two adjacent sides of a parallelogram, okay, are represented in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented in magnitude and direction. Then the resultant is represented in magnitude and direction by the diagonal passing through the common tail of the two vectors. Are we done? Done? Just a minute. Okay. Let me explain what it is. Statement is like this. If two vectors acting at a point are represented in magnitude and direction by the two adjacent sides of a parallelogram. So before I start this, let me tell you one thing. Triangle of vectors and parallelogram law of vectors mean the same. Okay, but with different perspectives. That's it. Why it is so, you will understand. See. So can someone read the statement? If two vectors are acting at a point. So how did we start triangle of vectors? Triangle of vectors also started with two vectors only. But how were those two vectors? So try to differentiate. So for triangle of vectors, what are the two vectors? Sorry, your voice.
Adjacent sides.
They're adjacent sides. Whereas when parallelogram law of vectors, how is it starting? When two vectors are acting. No. When two vectors are acting, there is another point. Two vectors are acting
at a point.
At a point means, in this case, there are two vectors only. We are starting with two vectors only. Unlike the triangle of vectors, so try to understand here. What is happening? In this case, A vector and B vector are adjacent. Here also A vector and B vector are adjacent. The only difference is here A vector and B vector are taken in order. Means the ending point of the first vector is behaving like the starting point of the second vector. Whereas in parallelogram law of vectors, both the vectors are starting from the same point. So the vectors which have the same starting point are called as co-initial vectors. Okay. So
again, sir.
Which point? Which point should I repeat?
Initial vectors.
So co means, I told you yesterday, co means same, initial means starting point. So if two vectors are having the same starting point, those vectors are called as co-initial vectors. That is another way of stating if two vectors are acting at a point. Okay, so the inner meaning of if the two vectors are acting at a point means, in some books they will also call it as co-initial vectors. Both mean the same, so don't get confused. I hope it is clear. Is it clear? Okay. So if two vectors are represented by the adjacent sides of a parallelogram, where both the vectors are acting at the same point, then the resultant of these two vectors is given by the diagonal which is passing through which point?
Common
Common
tail.
tail. So this is what is the tail. So A vector and B vector are sharing the common tail. Then the resultant is given like this, where this resultant is what is going to behave like the diagonal of this parallelogram. Okay. So let me explain what it is. Observe. Okay. So if this is A vector and this is B vector, then you can take another vector parallel to this. See, I'm doing a small construction. For example, when you learned the other chapters, right? When you have to prove something in triangles or something, you do the construction part. In a similar way, to prove this, I'm doing a construction. Observe how I'm going to construct. Because how many vectors are actually given to us? There are only two vectors given to us. So parallelogram can be applied if two vectors are there. Two input vectors, only if two vectors are known. Similarly, triangle law can also be applied if you know only two vectors. Because the third vector will be unknown and you will apply this formula and find it out. In a similar way, though we are saying parallelogram means our mind will start thinking that we need four vectors. Not necessary. We have only two vectors in our hand. We are going to find the resultant of these two vectors by doing a small construction. What construction I'm going to do is, I will consider a vector which is parallel to a vector of the same magnitude. I'm repeating it again. I'm considering a vector which is in the same direction as that of a vector and the same magnitude as that of a vector. So what will be the technical name of that vector? Equal vector. Very good. It is going to be an equal vector. I'm considering an equal vector a bar. So equal vector, and construction part I'm showing it with other color. Observe. Right, this is going to be A with a bar on the top of it. Now similarly, I am going to consider another vector parallel to B vector, that is in the direction of B vector and of the same magnitude. Then this value will be B vector. Yesterday I gave you the mathematical condition. Do you people remember? If two vectors are of equal magnitude and in the same direction, you can write them as, so then A vector will be equal to this thing. So if this is A vector, the equal vector to it is also A vector. If this is B vector, the equal vector to it is also B vector. Actually, we didn't have a parallelogram. But by doing the construction, we have completed the parallelogram such that for every parallelogram, there will be two diagonals. Right? This is one of the diagonals. And there will be another diagonal like this. Right? But what we are supposed to do is, you need to take only one diagonal for parallelogram law vectors. And which diagonal will you choose? The diagonal which is starting from the common tail. This is the diagonal we are supposed to consider. You should not take the other diagonal into consideration. Then this is what is called as the resultant vector. Okay, am I clear with this? Is there any doubt? Is there anything that you want me to repeat? Anybody? Are we good to go to the next topic?
Yes, sir.
Okay, then we'll proceed. See, now I'm calculating certain values. Concentrate. I'm taking the angle between these two vectors. Which two vectors? I'm taking the angle between the co-initial vectors to be theta. Okay. Now I'm going to find the value of the resultant, the length of the resultant in terms of the input vectors. What are the input vectors? A and B. Okay. So how I'm going to do, I'll show you now. So I'm writing this B vector inside observe. So this is also B vector. Now, if wherever I want length, wherever I want some relation with respect to length, wherever angle is involved, I immediately start thinking in terms of trigonometry. So if I need to apply trigonometry, obviously I need a right angle triangle. So how do I get a right angle triangle? By extending this portion and from this point by dropping a perpendicular. Okay, let me label them. So AB, CD, let me call this side as E. This is going to be the perpendicular. If this is theta, then this is also going to be theta. Am I right? Because this side and this side are parallel, they are going to be the corresponding angles. So it is going to be theta. Right? Now, AD vector is nothing but B vector. Accepted? Similarly, AB vector is nothing but A vector. If I ask you, I'll write one more point. AD vector is equal to BC vector. Can I call it as B vector? Similarly, AB vector is equal to BC vector. Can I call it as A vector? Am I right? Because they are equal vectors since they are equal vectors. Right? Now, what is going to be the magnitude of AB? Sorry, magnitude of AD vector is equal to magnitude of BC vector is equal to what? Anyone? So are you guys with me? So I'm asking, what is the magnitude of AD vector? If I say magnitude of AD vector is equal to magnitude of BC vector, I can call it as B. Am I right?
Yes, sir.
Okay. Similarly, magnitude of AB vector will be equal to magnitude of BC vector will be equal to A. Okay. Now, for you to understand things better, I'm removing the vector symbols and I'm just drawing a basic parallelogram so that it is easy for you to understand. So, if I take this as R, this is going to be theta. This side is A, this side is B, this side is B, and this side is A. I drop the perpendicular, then this angle is theta. Right? I took the sides as A, B, C, D, E. Okay, if I take the side to be theta, then if I consider the triangle BEC, I am taking a separate diagram of BEC for you to understand better. If I take this as BEC, if this side is B, then what is, if I take this side to be X and this side to be Y, what is X divided by B equal to? Anybody? Sorry?
Cos theta.
It is cos theta. Because adjacent by hypotenuse. So X will be equal to B cos theta. Similarly, what is Y divided by B? Sin theta, very good. Y divided by B is sin theta, so Y will be equal to B sin theta. What is that I need to find? I need to find the value of R. So, for finding the value of R, I am drawing another triangle. Observe. I am taking this point as A, this point as B, this point is E, and from A to the point C. Okay, so what I've done is, I've taken only this part of the diagram. So if I take this part of the diagram, can I draw it like this? Right? If this is the case, what is the distance AB? What is the distance AB? It is A.
A.
Yeah, distance AB is A. What is the distance BE? Distance BE is nothing but X, but we found out what is X. X is nothing but B cos theta. Similarly, what is the distance CE? CE is nothing but Y. We found out Y also. What is Y? It is B sin theta. So I hope it is clear till this step. So this is A, this is B sin theta, this is B cos theta, and this is R. Now what is it you are able to see? You are able to see a right angle triangle. Right? So for a right angle triangle, wherever you need to find the distances, then what do you apply?
Pythagoras theorem.
Pythagoras theorem. So what does it state? Hypotenuse square, that is AC square is equal to AE square plus EC square. Can I write it like this? Right.
Yes, sir.
AC, so AC square is equal to, can I write AE as AB plus BE the whole square plus EC square? Right. So what is AC? AC is R. So R square is equal to, what is AB? AB is A plus what is BE? It is B cos theta the whole square plus what is EC? It is B sin theta the whole square. Okay. Now I'm going to expand this. So on the right hand side, I have A square plus B square cos square theta plus 2AB cos theta plus B sin theta, the whole square is B square sin square theta. Now what I'll do is I'll combine certain times B square cos square theta plus B square sin square theta. If I take out B square, it will be cos square theta plus sin square theta plus 2AB cos theta. I hope it is clear till this step. Okay. Now what is going to be the value? A square plus B square into cos square theta plus sin square theta is what? 1. So A square plus B square plus 2AB cos theta. So this is nothing but the value of the resultant, R square. So what will be the value of R? R will be square root of A square plus B square plus 2AB cos theta, where A and B are co-initial vectors. And what does theta stand for? Theta is the angle between A vector and B vector. So if you know the angle between the two vectors along with the vectors themselves, then you can apply this formula to calculate the resultant provided they are co-initial vectors. So that is what this parallelogram law states. Okay. So tell me one thing. Are you people clear with the derivation part? You understood how we have derived this? So this formula?
Yes, sir.
Right. So this formula will be asked in your exam. More importantly, more than understanding the theoretical part, it is all about applications, where to apply, when to apply, and all those things that I will show you in the next class. Okay. So this part, till this part, I want you all to revise it for tomorrow, before tomorrow's class. So I'll give you 2 minutes time. If there is any doubt, you can get it clarified.
Sir, can you
Yeah.
show the diagram again?
Which part? Is this the diagram you're asking? Or the above one? This one?
Parallelogram.
The parallelogram, this one. Are you asking the one without arrow mark or with the arrow mark? This one?
Without.
Without. So this is the one you're asking, right? Okay.
Yeah.
So is there any doubt in the concept understanding? Anyone?
No, sir.
No? Okay. Others, if everyone is clear, we can just wind up. Okay.
Sir.
Okay then. Okay then, I'm ending the session. So I'll send you the link for math class in 5 to 10 minutes. Okay. See you all there.